Almost any state management library that implements the Flux pattern also provides support for middlewares. Now, what are middlewares? Now, middlewares are not something that comes with React, but they are implemented by the state management libraries like Redux and MobX, and they are a very powerful tool. In my experience, once you start using middlewares, there's no going back from that. They allow us to run side effects like API calls, logging, analytics, and other things in response to specific actions. And they allow us to register multiple middlewares so that we can perform different business logic on the same given action. And they also sort of simplify our view and move all the business logic to action creators. So let's look at what they are first. So this is our typical Flux application. We have our actions, and our views fire actions on which we write some reducers that we have registered with the dispatcher. And the reducers, which on updating the store, provide an event which the views can listen to. So where do the middlewares come in? Right in between the action and the reducers. They allow us to tap into any action and perform whatever business logic we want to. And then they pass the control to reducers. So how does that help us? Now out here, what we can do is we can register different middlewares. Let's say that we have a splash launched action that we have in this app. But what we want to do is we want to make an API call and maybe log that our splash screen has been viewed and also fire a pixel for that. One way to do that would be from our view. We call individual services. We call our home service and we make that API call. Then we call our logger service and log it on a network dashboard that we have set up. And maybe we also want to fire a pixel. Now, if you'd imagine we do all of that inside our view becomes very, very complicated and it's a little hard to manage. So what middlewares allow us to do is they tap into the action and now we can register different middlewares and they can all listen to the action and perform their own business logic of them. We've also used this in our application. So if you recall, we had the search thumb, this is the action creator. And inside this, what we did was when we wanted to make a request from the listings page, what we did was we called this thunk, and what this does is basically fires the action that a search has been initiated with this particular data, which has the query. And then we call the search service and then return the result. Now this one's quite a simple implementation, but we could have more logic to it, right? Everything that we need to implement as a part of the business logic. So let's assume for a second that we did not have this particular thumb and we never introduced the middlewares concept. What would happen in that case? So let's go to our listings page. And now we say that we don't have that middleware. So what we will do in that case? We will be doing something like this. So we'll not call the middleware. What we'll do is we'll say search service dot fetch, and we will be passing the query. And now when we have our result, now when we have our data, we'll be doing a dispatch and we will say type action types dot search dot, and maybe we had a search succeeded, and then we would say transfer data to it. This is how we do it. But let's say we had even more things. Right? As you can see here, now our view is starting to look like it has some sort of a business logic. Now this is quite simple. We're just making a request to the search service and then dispatching an action to save that. But it can be a lot more than that, right? And we don't really want the business logic to be part of the view. And what we had previously was quite simple. We just said that we'll dispatch an action from search and we would get the result. We don't care about what really goes into implementing that particular action. The view doesn't need to worry about that. So that way it makes it really, really simple. We'll also take the example of the card thunk. Now in this one, when adding items to cart, we'll dispatch an action that says add item to cart with the particular item. Now, this can also be a network call where we want to save the car on our server side for that particular user. So we also need to see whether the user is logged in or not. So that becomes an additional logic. So we'll say save server side card, but before that, if user logged in, then save on server side, else maybe save on local DB, which can be the async storage. And then we get the response. We update the store. So that can be handled by the reducer return for this. And finally, when all of this is done, we update the card back with the number of items that we have in the cart. Now that is a lot of logic. And if you were to implement that in a view, our view will start getting very, very complicated with a lot of business logic in there. So that way, thunks are really, really beautiful. And not just API calls. We can do all sorts of other middlewares that we want to. Like we can have a middleware for logging, for analytics, and a lot of different use cases that we can think of, and any enterprise application can probably have. The second thing that the thunks allow us to do is they allow us to control the order in which the actions are fired, and also the middlewares. And how we do that is they're basically fired in the order that they are registered. Now, if you would recall, we said that the logger middleware needs to be the last one to be registered. We said that because we want all the state updates to happen and then log the final state of the application. So if you see here, we have added the logger middleware as the last one. And that's exactly the reason for that. So what does a thunk look like and how do we implement one? Before that, I just wanted to show you the logger middleware that we have. We already added the Redux logger middleware. And we have it in dev dependencies because we don't really want it to be in production. And what that basically allows us to do is it logs the state before and after any action. So it says previous and it says is loading true, and the next state which becomes is loading false. So what we'll do is we'll implement a simple logger middleware and see how it works. So let's go to Redux and create a folder that says middlewares, and we will say logger middleware, right? And basically the middlewares have this particular format. We'll say logger, and we get store, and then the next is a function and the action that we need to capture. This might look complicated. What basically this is implementing is something that's called currying in JavaScript. What currying is that it's a technique of converting a function that takes multiple arguments into a sequence of functions that take a single argument. So if we take this particular function and implement that, what this would effectively become is this. So we have this nested function. At the root, we have logger, which returns another function with a parameter next, and then which again returns another function with parameter actions. So that is what this particular syntax represents. Next, let's implement the logger. We'll say console.log, and we'll say initial state, and we'll get the state from sto.getState. So this is the same function. Next, let's call the action and perform it. Next, and then action. Now we have the result and the state should have been updated. So we'll print the final state or the next state, and finally return the result. So this becomes a very simple logger that we have implemented ourselves. Next, let's integrate this to the store, we'll say logger from middleware slash logger. And let's not integrate this, and we'll apply the logger that we have written. Let's save that. And I'll bring back the React Native debugger, and let's refresh the app. So once we launch, there we have it. We have this data from the logger, we said initial state, and if we look at it, we have is loading as true. And the next state, it was is loading as false. So you see how our logger has now intercepted every action that is going to be fired in the application and performs some business logic based on top of that. And that makes it very, very powerful, right? And this is all asynchronous. Let's also implement a crash reporter. We'll be integrating Sentry in one of the upcoming lessons. Though let's say that we wanted to implement our own version of a crash logger. Let's do that. So we'll just copy over this function and we will say crash reporter. And then what we want to do is we want to put this in a try catch block. And we'll basically let the application perform the action. And in case there is any error, it will come to the catch block. And in the catch block, what we can do is we can do console.l, and we can log the error. Also, maybe we can push this to our error logging dashboard. And finally, we just throw back the error. So again, integrating this is very, very similar to what we did for our custom logger. And we can say that we want a crash reporter. And once we save, let's also print what we are getting. Console.log crash reporter, and we'll print action.type. Let's save that. Let's print back the React Native debugger. And if we see here, we already have the crash reporter with the action type. So all we need to do is in the catch block, we need to push it to any dashboard that we want. And we have our basic version of a crash reporter implemented. So as you can see, we did not change anything in other parts of the application, but Redux and MobX, they do support middlewares. And with that concept, we just registered whatever middlewares we wanted to create while creating the store. And they all could listen to every action that is fired in the application. They get the data, the store data, the initial state and the final state. And if they want to log something from that, we can do all of that using these middlewares. And these are just two examples. One is a logger, another is a crash reporter. We can do analytics, and we have already seen API calls. So that means these middlewares, the thumb that we have, they allow us to aggregate all the business logic into a single place. So let's say that we wanted to implement an analytics middleware. What we could do was create our own implementation. And then while firing a particular pixel, we can get the data from the store. And let's say that we also fired some additional data that's required only for tracking purposes. So we'll say action.tracking. And we can have some custom logic too. So whenever we fire any application, and let's say that we have a tracking object attached to it, only then do we fire a particular pixel. In more advanced versions, what we can do is we can have something like this. And let's say that we have multiple tracking services integrated into our application. So this also allows us to handle that very, very effectively. Let's say we have a Google Analytics service and some other marketing service. So on app launch, we want to fire both of them. But on search page, we only want to fire analytics service. We can do that too. So as we can see, middlewares are a very powerful concept that comes with almost any application that implements Flux. So one last thing before we wrap up, let's also declare the types for that. So we go to our implementation, the middleware implementation. And let's declare the types. So these are our middlewares. This is provided by Redux. And let's also add it again. And what we get from this is basically a store. So a store has a dispatch and an action. So let's declare a store type. Interface store dispatch. This is of type dispatch. And we'll do any action. And secondly, we get a function that turns the state. So for our case, it will be the root state. And then finally, type of action is what we defined earlier. It will be I action, the type N. So we just also copy that over to the crash reporter. Okay. That should be good. We can confirm that by going to our store where we have created, and that's the logger and the crash reporter that we're passing. So that's all for this module, and I'll see you in the next one.